Hey guys, in this tutorial, I want to walk you through an activity that we started in class. We were analyzing the test results for 20 students in a class. So we took a look at what the definition of percentile means, and I think we even got to spend a little bit of time today in interpreting or at least calculating what a z-score is. I want to quickly remind you, in case you didn't get it in class, all a z-score is doing is it's taking the data that you already have and it's standardizing the data so that we can easily measure how many standard deviations away from the mean we are. Now, this can be confusing because we're told that the standard deviation is 10 points on this particular assessment, but that's just our ruler or our yardstick. It's like a unit of measurement. So if I want to standardize that 10 standard deviations, I want to turn the 10 into a 1. And I know that's confusing, but that's just one length. That's how long a single standard deviation is. So the mathematical formula for calculating a z-score is to take your observed value, which on number 6, my observed value was 98 because that's what Goldie made. I subtract off what I expected her to make, and then I divide that by the yardstick of 10 standard deviations. Well, that tells me that she is now 1.8 units, so 1.8 of those standard deviations above the mean. To interpret it, you want to make sure you use the word average, and you can round it in this case for our interpretation. Since her z-score is 1.8, it's not quite 2. She's almost 2 standard deviations above the mean score of 80. So the big ideas for this particular activity is I want to make sure you know how to interpret what a standard deviation is, and I need you to know how to calculate z-scores and what the purpose of them are. So it just allows us to level the playing field so that we can compare different units of measurements to one another. If you need to pause the video so that you can copy those down, please do. What I want to do now, though, is I want to take a quick look, well, as quick as we can, at this problem at Knoebels Amusement Park in Pennsylvania. We have the prices of some rides. It's plotted there. And what I did is I went to my graphing calculator and I actually plotted this data in my calculator. And you can see as I scroll down, I put all, gosh, I think it was 22 rides that I had. Yeah, into list 1. The question, and I'm just trying to prove a point to you, I do want you to actually plug this data set into your calculator so that you can see what happens. From time to time, you're going to be asked to transform your data, and you have to know what happens to the distribution when you transform it. So what we're going to do on number 1 is we're going to convert from dollars to cents. Well, we know there's 100 cents in a dollar. So now I'm going to go to my data and I'm going to hover over L2. That's key here. And what you're going to tell the calculator to do is you're going to type in second L1. I'm going to say that again. Type in second L1, and then you're going to hit a times button, and then you're going to do 100. And what you're telling the calculator to do is to take every single entry in L1 and multiply it by 100, because we want to convert all of those numbers quickly to cents rather than dollars. And as soon as I hit enter, automatically all that data switches over. So that's the first step. I'm going to go back to my assignment, and it says we're asked to describe the shape, the mean, and the standard deviation of the distribution when it's in cents. Well, I want you to think about it. If I switched all of these numbers down here into cents, wouldn't the distribution still remain the same? It would make sense that the shape is going to remain the same. But the mean is no longer going to be 1.705. And I don't know what's going to happen to the standard deviation. So let's do a little investigation and we'll go to our calculator. Remember, my pennies are now in list 2. I'm going to go stat, calculate, one variable statistics. I want to make sure I'm pulling my data from list 2, not list 1. I'm going to scroll down to calculate and I'm going to hit enter. So something interesting happens. My new X bar, my mean, is no longer 1.705. My new mean is 170.5. So all that happened was my mean got multiplied by 100 also. So we're going to go to our paper. Oops, sorry. And I'm going to, with the magic of recording, and here you go. Like I said, with the magic of recording, I was able to quickly pop in my answers. So now let's review this. We said the shape remains the same and it's still skewed right. The mean actually went from 1.7 to 170. If you think about it, all that happened was the mean got multiplied by 100 as well. And then take a look at our standard deviation. Where I found my standard deviation was on my calculator. It's right next to this SX. SX stands for the standard deviation of a sample set because we're taking a sample. I got 44.7 here, and I noticed that my standard deviation on my original data set was 0.447. Again, we multiplied by 100 to get that new standard deviation. It's super important that you take the time to plug these data into your calculator so that you can actually see firsthand what's happening. Now let's move on to number 2. Number 2 wants us to take the data from number 1, which was already multiplied by 100, and to increase the cost of each ride by 25 cents. Well, that's a plus 25 cents, right? So let's go to our calculator. Let's go to stat, calculate and edit, edit. Now I'm going to hover over L3, and I want to make sure that the highlighter's on L3. What I want to do is I want to take my answers from question 1, make sure you read the question carefully, but take your answers from question 1, which is in list 2. So I'm going to do second L2, and now I'm going to add on 25 cents, 25 pennies. I'm not going to type it in as a 0.25 because remember, I'm adding it to L2, which is already in pennies. And then I'm going to hit enter and hopefully it'll populate. I'm going to run one variable statistics on list 3. I'm going to change that second L3. And then I'm going to go down and I'm going to calculate it. And I want to see what happens to this data set. Now, my mean has changed to 195.5. So let's go to our problem. And let's just talk for a minute about the shape. If I added 25 cents to every single one of these dots, wouldn't you think that every dot would just move to the right by 25 cents, correct? So the whole shape is still going to stay the same, but everything gets shifted to the right. So with the magic of recording, so I'm able to show you the answer. And the way I got this is the shape, remember, is still going to be skewed to the right. The reason for that is every one of these values is going to be first multiplied by 100 like we did in number 1. So this is really 125, 150, 175. But then if you add 25 cents to every dot, those dots are going to be shifted to the right by 25 cents. So the distribution still remains the same and skewed to the right. It's just shifted to the right. The mean, then, it makes sense. Isn't the mean also going to move with the shift of the distribution? So the mean, according to my calculator, hopefully you see it on yours, is actually 195.5. And the way we got that was by taking 170.5 and adding 25 cents to it. So the mean increased by 25. The standard deviation, interestingly enough, though, didn't change. Now, why is that? Well, let's think about it. If the shape is still the same as in number 1, the variability shouldn't change. So by adding 25 cents. So when you add or subtract a value, your standard deviation is unchanged. The only time your standard deviation does change is when you're multiplying or dividing. And before we wrap up this tutorial, I want to quickly take a look at number 3. What if we took all of these numbers from list 3 and we converted them to z-scores? What's the shape, what's the mean, what's the standard deviation going to look like? And this is what I need you to know. The shape will still remain the same. But the mean, the average, is going to become 0. When you standardize data, when you get z-scores, your mean is always 0. You might want to highlight that in your notes because that's a big idea. And the standard deviation becomes 1. So that is a note that you might want to put up here at the top. Please know that when you standardize data, your shape doesn't change, the mean becomes 0, and the new standard deviation is 1.